All right, welcome back. We've spent some time on the fundamentals of cloud networking, but today we're going expert level. We're moving past just getting connected and diving deep into building architectures that are truly resilient and can handle massive scale. So let's just jump right in with a question that probably keeps a few of you up at night. I mean, it's one thing to get your network connected to the cloud. It's a whole other ballgame to have a connection you can bet your entire business on, especially when things go wrong. You see, in this explainer, our goal isn't just to be connected. That's table stakes. We are aiming for unbreakable. We're going to build a playbook for resilience and scale that can handle pretty much anything you can throw at it. Okay, let's get into that. Our first challenge. How do we create connections that are designed from the ground up to never ever fail? First off, let's get on the same page with this term high availability, or HA. Now, this isn't just a buzzword for having a backup. It's a whole design philosophy, a commitment really to ensure your network delivers a guaranteed level of performance no matter what. And this is what that commitment looks like in practice. 4 nines. 99.99%. That's the service level agreement for a Google Cloud HAVPN. Let's put that in perspective for a second. That's less than 1 hour of downtime over an entire year. It's pretty much the gold standard for any connection you'd call business critical. So how in the world do they pull that off? Well, the magic is all about redundancy. Instead of one tunnel, you get two, each with its own IP address. Then it uses this thing called BGP, which is basically the GPS of the internet. It constantly checks the health of both tunnels. If it senses even a hint of trouble on one, bam, it instantly reroutes everything through the healthy one. Your users, they won't feel a thing. Okay, so HAVPN is amazing for reliability. But what if you need more? I'm talking more speed, more security, more raw bandwidth that a connection over the public internet can give you. That's when you bring out the big guns, Dedicated Interconnect. I want you to think of this as your own private, multi-lane superhighway that goes directly into the cloud, completely bypassing all the traffic and chaos of the public internet. And this table here, it just lays out the choices so clearly. A VPN is fantastic, gets you in the game, but you're talking a few gigabits per second. With Dedicated Interconnect, though, you jump to a mind-blowing 10 or even 100 gigabits per second per link. That is a whole different league, an absolute game changer for big data, finance, or media workloads. The main thing to know is you'll need to be in a colocation facility to plug in directly. And don't think this is some niche thing you can only get in Silicon Valley. We're talking about a massive global footprint. Major hubs across North America, Europe, Asia, South America, Australia. Basically, wherever your business is, you can get that private on-ramp to the cloud. Okay, so our connection is now rock solid, bulletproof. But this brings up a new challenge. A good one to have, by the way, success. What happens when a ton of traffic suddenly shows up at your front door? You don't want to fall over. And the answer isn't just to throw more servers at the problem. No, the smart way to handle this is with a killer combo. An intelligent traffic cop at the front door, that's your load balancer, and an infrastructure that can magically grow and shrink on demand. And this image just illustrates it perfectly. Look on the left, 2 servers getting absolutely hammered. CPU is through the roof. The autoscaler sees this and basically says, nope, not on my watch. It automatically adds a 3rd server, the load balancer spreads the work out, and now look on the right. Everything's running cool and easy. It's beautiful, hands-off elasticity. And the really crucial takeaway here is how much control you have. You get to decide exactly what triggers a scaling event. It could be something simple like CPU usage or the load on your load balancer, or you can get super sophisticated and trigger it off custom metrics. You can even do it based on a schedule, for that big Black Friday sale that you know is coming. And here's what that looks like in the real world. It's surprisingly simple. You just set your minimum and maximum number of instances so you don't scale to infinity and get a surprise bill, and then you tell it what CPU target to aim for. That's it. You've just built an elastic system. Okay, but this brings up another super critical question. An instance might be running, but what if the app on it has crashed? The last thing you want is to send a user to a dead end. And the answer is just brilliant. Health checks. They enable this feature called auto healing. Think of it like a little robotic doctor that's constantly checking the pulse of your application on each server. If one of them becomes unresponsive, the auto healer just takes it out back, terminates it, and spins up a brand new, healthy replacement. It ensures traffic only goes to servers that are ready to do the work. So, we've covered a lot of advanced stuff here. Let's pull it all together into a simple, actionable playbook that you can use to design your own unbreakable systems.
Here it is, your 4-step playbook for an unbreakable network. First, build your foundation on resilience with HAVPN. Second, when you absolutely need that raw power and privacy, level up to Dedicated Interconnect. Third, handle any traffic spike by pairing a load balancer with autoscaling. And finally, guarantee your uptime with health checks and auto-healing. You get these 4 pillars right, and you are building a world-class system.
So there you have it, the patterns you need for an unstoppable network. But as you expand across the globe, a whole new complex challenge pops up, right? How do you deliver this amazing performance everywhere in the world without your costs spiraling completely out of control? Well, that sounds like a great topic for another explainer.